When you first start coding, you might think programs just run straight from top to bottom, one line after another. But that's not where the real power is. The real magic happens when your code can start to think for itself, when it can make decisions, repeat actions, and react to different situations. That's what Python's flow control is all about, and it's how we're going to make our code genuinely smart. So that brings up a big question, right? How does a program actually choose what to do? Or how does it know to repeat something a bunch of times? Or, when to just stop? The answer to all of that is a core concept called flow control. Simply put, flow control is what dictates the order in which your code runs. So instead of just marching down a straight road, flow control lets us build forks in the road, little detours, and even traffic circles that let our code loop back on itself. This is really the fundamental difference between a simple script and a truly dynamic application. All right, so here's our game plan for today. We'll start by talking about the tools that let your code make decisions. Then we'll get into repeating actions using loops. After that, we'll see how we can get really precise control over those loops. And finally, we'll put it all together and build something that looks pretty complex, but you'll see it's actually made from these simple parts. So think of it like this. We're adding three main types of tools to our programming toolbox. We've got conditional statements, which are all about making choices. Then we have iterative statements for repeating things. And finally, transfer statements, which let us change a loop's behavior right in the middle of its run. All right, first up, let's tackle making decisions. This is all about teaching our code how to ask a question and then act based on whether the answer is true or false. And the most basic tool for this is the if statement. I want you to picture it like a bouncer at a club. It checks a condition, like checking your ID. If that condition is true, it lets the code inside run. But if it's false, the program just walks right on by that block of code. Okay, let's see what this looks like in actual code. The first line asks the user for their name, but the second line is the important one. We have the if keyword followed by our condition. Name equals Durga. That double equal sign is super important. It's not assigning a value, it's checking if they're the same. If they are, the indented code right below it gets to run. And notice that last print statement? It's not indented, so it's outside the if block. That means it runs every single time no matter what. And boom, there's the output. We typed in Durga, the condition was true, and it printed that special greeting. Perfect. But what happens if the name isn't Durga? Right now, our code just skips that special greeting and moves on. What if we wanted to do something else instead? Well, that's exactly what if-else is for. It gives our code a plan B. It's like a fork in the road. You either go left if the condition is true, or you go right if it's false. It makes sure that one of those two code blocks will always run. So, if we take our last piece of code and just add this else block, now the logic is complete. The program still checks if the name is Durga. If it is, we get the special greeting. But now, for anything else, it jumps down to that else block and runs that code instead. And check it out. This time, the input was Ravi. The program checked. Nope, not Durga. So it immediately jumped to the else path and printed the generic guest greeting. With if-else, you're covered, no matter what the outcome is. Okay, but what if life isn't just a simple yes or no? What if you have like 5 different options? That's where the if, elif, else ladder comes into play. Elif is just short for else if. The program checks the first if. If it's false, it moves to the first elif and checks that. If that's false, it moves to the next one and so on, all the way down the ladder until it either finds a condition that's true or it hits the final else at the bottom, which acts as a catch. Okay, so our code can now make decisions. That's a huge step. Next up, let's teach it how to be efficient by doing things over and over again, all by itself. We're talking about the magic of loops. So an iterative statement, or, a loop, has a really simple job. Run the same chunk of code multiple times. And in Python, we've got 2 main ways to do this, the for loop and the while loop. And this slide breaks down the difference perfectly. The for loop on the left is like a checklist. You use it when you have a collection of items, like a list of names or the characters in a string, and you want to do something to each one. The while loop on the right is different. It's more like a guard on duty. It keeps running the code as long as a certain condition stays true. Let's see a for loop in action. It's super readable, which is one of the things people love about Python. We've got a string called s. The loop for x and s basically says, for every single character inside of s, let's temporarily call it x and then do the indented action. In our case, that action is to just print out x. And there you have it. The output shows exactly what the loop did. It went through the string Sunny Leone,
character by character, including the space, and printed each one on a new line. Simple, elegant, and totally automatic.
All right, now let's look at the while loop. The setup is a bit different. You need 3 parts. First, you have to initialize a variable, kind of like a starting line. Here, it's x equals 1. Then you have the while condition itself, the thing it checks every single time it loops. And this last part is so important. Inside the loop, you have to update that variable. If you forget that x equals x plus 1 part, x will always be 1, the condition will always be true, and your program will be stuck running forever. That's an infinite loop, and you definitely want to avoid those.
Okay, awesome. We can make decisions, we can loop, but sometimes we need even more control inside those loops. What if we need to bail out early? Or maybe just skip one little part? That's where our next set of tools, transfer statements, come in.
First up is break, and I want you to think of this as the big red emergency stop button on your loop. The loop is chugging along, doing its thing, but the instant your code hits a break statement, bam, it stops dead in its tracks and the program jumps to the very next line after the loop.
This shopping cart example is a great way to see it. We're looping through the prices in a cart. It prints 10, no problem. Prints 20, we're good. Then it hits 600. The if statement sees that it's over 500, prints the warning message, and then hits break. And just like that, the loop is over. It never even gets a chance to look at the 60 or 70. Now, continue is the sibling of break, but it's way less dramatic. It doesn't stop the whole operation. Instead, it just says, hey, let's just skip the rest of the work for this one item and move right on to the next one.
So let's see this with our cart again. It prints 10, it prints 20. When it gets to 500, the if condition is true. It prints the cannot process message and then continue, tells the loop, all right, that's it for 500, let's go to the next item. It does the same for 700, but then it gets to 50 and 60, the condition is false, so it just prints some like normal. See the difference? Break ends the party, continue just skips a song.
All right, we've got all our tools on the table now. Conditionals, loops, transfer statements. They're powerful on their own, but the real magic, the real creativity in programming comes from putting them together.
So to wrap this up, let's take on a little challenge. We're going to print this pyramid of stars. Looks kind of complicated, right? But I promise, we can build this with just the tools we've covered today. Okay, let's peek under the hood at the code. Don't worry about memorizing every little detail. The big idea is this. We have one main for loop that handles each row of the pyramid. And for every single row, it does 2 simple calculations. First, how many spaces to print on the left to get the alignment right, and second, how many stars to print for that specific row.
And look at that! A perfect pyramid. This is what it's all about, taking simple logical building blocks, in this case, just a loop, and combining them to create something that looks really cool and complex. It's not magic, it's just flow control. So there you have it. We've seen how to make our code think with if statements, how to make it repeat tasks with for and while loops, and how to fine-tune those loops with break and continue. These are the absolute fundamentals for making your programs smart and dynamic. Now you have the tools, so the only real question left is,